Alright, so here's what we're going to go over for this week, and this is the week of April 20th, so today is April 20th, 2020. We are on COVID-19 week number 5 or number 6 here, and we're going to go over two different ways on how to solve quadratics. First way is going to be the square root method, and the second way is going to be what we call completing the square. Okay, so the first thing is the square root method of how to solve quadratics. So when you're using the square root method, you're always going to be given equations that are quadratic. So remember that you're going to see an exponent with a 2 in it, and the highest exponent will be a 2. And then typically when you're using the square root method, you're going to see something like this. So you're going to see a quantity in parentheses like this to the second power, and then typically it's going to be equal to some value, like let's go ahead and make it equal to the value 49. Okay, so what you're going to do in this problem is that we are going to be solving for x, which means that we're going to have to be isolating the variable x. And the way that we're going to isolate the variable x is we're going to get rid of the 2, and then we're going to get rid of the plus 3. So we're going to get rid of the exponent of 2 first, and then we're going to get rid of the constant positive 3 second. Okay, so how do you get rid of an exponent of 2? So remember in math, when you want to get rid of a value, you do the opposite math operation to get rid of it. So the opposite math operation of an exponent of 2 is the square root. Okay, so our first move in this problem is that we are going to take the square root of both sides of the equation. Okay, and we'll learn in the second example that you don't want to take the square root until you have this parentheses, this quantity by itself. All right, so now what does this do when you take the square root? Well, this square root symbol, since it's the opposite of the exponent of 2, they actually cancel each other out. And then you can see that you're left with x plus 3, and you could drop the parentheses because you don't need it anymore because that exponent of 2 got eliminated. And that's going to be equal to whatever the square root of 49 is. Okay, now, common mistake, we all know that 7 times 7 is 49. So many people would say the square root of 49 is just 7. And if you say that, you're going to miss half of you're half right, but you're also half wrong. So the square root of 49 is not just positive 7, it's also negative 7. Okay, so why is that? Well, remember that 7 times 7 is indeed equal to 49, positive 7 times positive 7. However, negative 7 times negative 7 is also equal to 49. So we say that the square root of 49 is equal to positive or negative 7. Okay, and then we're just going to continue to solve to figure out what x is. So we're going to minus 3 from both sides of the equation, or subtract 3 from both sides of the equation. And after these 3's cancel out, you can see that we've isolated the x. And x, we're going to end up with two answers for x. One of my answers for x is going to be positive 7 minus 3. So positive 7 minus 3. So that's equal to 4. And then my other answer for x is going to be negative 7 minus 3. And negative 7 minus 3 is equal to negative 10. So for this problem, if we said solve for x, we're using the square root method, we would say that x is equal to negative 10, you put a comma, and you put a 4, and both of those answers are actually the solution to this equation. So what does that mean? It means that if I went back to the original equation, okay, and you can see here, so if I went back to the original equation, which was quantity x plus 3 squared is equal to 49, I could check both of my answers to see if they actually work. So that means if I substituted in a negative 10 in the place of x, my equation would become negative 10 plus 3 to the second power, and then I would check to see if that actually equals 49. Okay, well, negative 3 plus 7 is equal to negative 7. And negative 7 to the second power is indeed 49. So you can see that when I check my answer and I substitute in negative 10 in the place of x, it checks out. Now let's do the same thing for positive 4. So if I take this equation and in the place of x I substitute a positive 4, my equation would become 4 plus 3 to the second power is equal to 49. 4 plus 3 is 7. 7 to the second power is equal to 49. So you can see that no matter which number I substitute into the place of x, both of them work, so that's why we have to say that both of these solutions are actually the solutions. Okay? Number 2. Let's say we have x minus 6, quantity to the second power, and then we have a minus 17, and then that is equal to, let's go ahead and make it equal to 64. Okay, so in this problem, you can see that just like in number 1, we have a quantity to the second power, but we have this minus 17 after the quantity to the second power, and it's equal to 64. Okay, so if this is the case, before you take the square root to eliminate the exponent of 2, the first thing we want to do is we want to take this value right here and we want to move it over to the other side of the equation by adding 17 to both sides. So when I add 17 to both sides of the equation, my new equation becomes x minus 6 quantity to the second power, and then that's going to be equal to 81. 64 plus 17 is 81. Okay, now I'm going to continue to solve the equation just like I did in example number 1. So I'm going to eliminate the exponent of 2, and I'm going to do that by taking the square root. And why do I take the square root? Well, because the square root is the opposite math operation of an exponent of 2. I have to square root both sides of the equation. When I do that, that square root symbol, radical symbol we call it, cancels out the exponent of 2, leaves me with x minus 6, and I could drop the parentheses because they don't mean anything. And then I'm going to take the actual square root of 81. And remember, we know that it's 9, but we know that it's not just positive 9, it's positive and negative 9. So the square root of 81 is positive and negative 9. Continuing to solve this equation, I'm going to add 6 to both sides of the equation. The 6's are going to cancel out, and I'm going to get x is equal to, and at this point, once again, I have to figure out what are my two answers. I'm going to get two answers. My first answer is going to be the case when it's positive 9 plus 6, which is equal to 15. And my second answer would be the case of negative 9 plus 6, which is equal to negative 3. So you need to denote or write or be aware of, however you want to say it, that both of these answers are the solutions. So my final answer, my solution to this equation would be x is equal to negative 3 and 15. Okay, so that would be how we go about solving by doing the square root method. Okay, so now let's go on to our second way to solve quadratics, and this would be when we do a method called completing the square. Okay, so this will be our second method on how to solve these quadratics, and this is a method called completing the square. Okay, so completing the square. Now, you will notice that when I show you a completing the square equation, or an equation where we're going to use completing the square, the equation looks very different than the one when we're using the square root method. So we have x squared plus 8x plus 7 is equal to 0. Plus 8x plus 7 is equal to 0. And you hopefully can see right away when I compare my notes from when I use the square root method here. So you can see when I use the square root method, and let me just fold the paper so it just shows up a little bit cleaner on the notes here. You can see that, well, what's the main difference between the square root method? Where the equations, what do they look like? Well, you can see there's no parentheses in this one, but there is a second power. So this is a quadratic, but there's not the parentheses part. Okay, so you're going to use completing the square when you don't have the parentheses to the second power. And actually, you'll learn that as we go through the process here, we're going to actually be using the square root method, but we have to set it up. So here's the first thing that we're going to do in this problem. So remember when you have a, this right here is called a quadratic in standard form. And remember we have an a value, and my a value would be 1. We have a b value, which would be 8, positive 8. And then we have a c value, which would be positive 7. So when you're solving by completing the square, the first thing you always want to do is you want to take your c value and you want to move it to the other side of the equation that the a and the b value are on. So I'm going to minus 7 from both sides of the equation here. Okay, those 7s will cancel out, which means I will no longer have a c value sitting here. And I'm going to have x squared plus 8x. And then I'm going to leave a gap right here, and I'll explain why in a second, and that's equal to 0 minus 7, which is negative 7. Okay, and now what we're going to do is we are going to create a new c value. Okay, so your first move is always to get rid of the c value and move it to the other side, but now we're going to create a new c value right here. And whatever we put for our new c value, so this will be our new c value, so I'll put it in a different highlighted color here. Whatever we put right there, we're going to have to add a new c value to both sides of the equation. Okay, so how do we do this, get this new c value? Well, this is where we're going to use the process of completing the square. Okay, so how do you complete the square? Remember, here was the strategy to complete the square. You take the b value, which is positive 8. You divide it by 2. That's going to give you 4. And then whatever that is, you raise it to the second power, and that's equal to 16. And that will be your new c value. So we're going to add a 16 to both sides of the equation. Okay, so, and we're going to use this process right here. Remember, this process is called completing the square. So now what we did was we created this trinomial here. It's a new trinomial, but if you recall, this trinomial right here is called a perfect square trinomial. So my next step is I'm going to factor that trinomial out. Okay, so I'm going to factor this trinomial, x squared plus 8x plus 16. So how do we factor that trinomial? Well, remember, to factor a trinomial, think of the t-chart. You're going to have to find 2 pairs of numbers that multiply to make your c value positive 16. But those same 2 numbers are going to have to add to make your b value positive 8. So I'm going to write down all the pairs of numbers that multiply to make 16. There's only 3 of them. 1 times 16. 2 times 8, 4 times 4, and which one of those pairs actually add to make 8? Well, you can see that's 4 and 4. So positive 4 and positive 4, those are my factors. So remember, a trinomial will always factor into 2 binomials. They're both going to start with x because my variable is x. And since both my factors are positive 4, I'm going to have x plus 4 and x plus 4. And that's going to be equal to negative 7 plus 16 is 9. Okay, well, I'm going to rewrite this. I have 2 sets of x plus 4s. So I'm going to have x plus 4 to the second power is equal to 9. Okay, and now, hopefully, if you're following along with this, you say to yourself, hey, wait a second. That equation looks just like, or it's kind of like the one where we did right here, when we solved by the square root method. And you are exactly right if you're thinking about this. So now we're going to continue to solve this by using the square root method. So we're going to take the square root of both sides of the equation. That is going to eliminate this exponent of 2 because the square root would cancel it out. And then we would be left with x plus 4, and we could drop the parentheses because the 2 got eliminated, is equal to, and what's the square root of 9? Remember, it's positive or negative 3. Okay, continuing to solve, we're going to subtract 4 from both sides of the equation. And after these 4's over here to the left of the equal sign cancel out, we get x equals, and then once again, we are going to end up with 2 solutions to my equation here. One of these solutions would be positive 3 minus 4, which is negative 1, and my other solution would be negative 3 minus 4, which is negative 7. So in this particular problem, x is going to be equal to negative 7 and negative 1, and you could just write them both and separate them by a comma. So that would be the first example of how to complete, that would be an example of how to complete the square of a quadratic, okay? And we did this last week, and we did this the week before, so this should not be a brand new example to you on how to do this. All right, but let's go ahead and let's do another one here. So let's do a second example of how to solve an equation by completing the square. But in this example, you're going to see that the answer or the solution is not going to come out to be some super nice, friendly equation. So we have x squared plus 12x, and let's go ahead and make it equal to negative 4. So you could see that right away that in this problem, unlike the first example, my c value, I don't have to move it over to the other side. So I've already moved it over. Okay, so what I'm going to do is I'm just going to use the process of completing the square. So my first step here is I'm going to create a new c value. Okay, and remember, whatever I create for my new c value right here, I have to add it to both sides of the equation. So I'm going to have equals negative 4 plus, and then I have to have whatever my new c value is going to be right here. Okay, so how do I create the new c value? I'm going to use completing the square. I'm going to make what we call a perfect square trinomial. All right, so I'm going to take my b value right here, which is positive 12. Remember, I'm going to divide it by 2. That is equal to 6. Then I'm going to evaluate that to the second power. 6 to the second power is 36. And that's going to be my new c value. And I have to add my new c value to both sides of the equation. Then my next step will be, I will take this trinomial, which is a perfect squared trinomial, and I'm going to factor it out. Okay, so how do I factor it? Well, I could use the t-chart, or remember, when we complete the square, these will always factor into the same number twice. So I have to find two numbers that multiply to make 36, but at the same time they have to add to make 12. Well, I'm going to skip writing all the pairs, and I'm just going to just go to, I know that 6 times 6 is 36, and 6 plus 6 is 12. So that means my two factors are x plus 6 and x plus 6 for x squared plus 12x plus 36. And that's going to be equal to, and I'm going to negative 34 plus 36 is 32. Okay, so now this means I have two sets of x plus 6. So I'm going to rewrite this as x plus 6 to the second power is equal to 32. And now I'm going to use the square root method to solve this equation out. Okay, so I'm going to take the square root of both sides of the equation. Why do I do that? Once again, because this square root symbol, the radical symbol, cancels out to 2. And then I have x plus 6 is equal to the square root of 32. Now, here's where you have to be careful on these answers right here. So the square root of 32, if you notice, and I'm going to use my calculator here to show you, and hopefully you can see it get worked out. Try to get it out of a spot where, there we go. So the square root of 32 turns out to not be a perfect square root number. You can barely see that. There. Hold on. There we go. It's 5.656854249. Okay, so if you get a decimal, I'm okay you're using a decimal. Let's go ahead and just say this answer is, well, actually, you know what? Let's not get lazy. So if you get a square root that is not a perfect square root, the first thing we know is that it's going to be a plus or minus, a positive or negative, and then what we have to do is when we get a square root, we're going to have to make a factor tree out of 32. Okay, so you're going to have to simplify that radical symbol. So give me two numbers that multiply to make 32, 8 and 4. Whoever said that, great job. And then I'm just going to keep factoring until I can't factor anymore. So 8 can be factored into 4 and 2. 4 can be factored into 2 and 2. So I have a bunch of 2's here, but I'm going to go to my other part of my factor tree, my other root, I guess. This 4 can be factored into 2 and 2. So that means when I take the square root of 32, and when I factor it, it factors down into 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2. And this is what I want you to do if you end up having to take the square root of a non-perfect square number. I don't want a decimal. I want you to actually give me the simplified version of it. Okay, so what does that mean? So remember, that means that now, anytime I have identical pairs of numbers, I am going to eliminate them from the inside of the radical symbol, and they're going to jump to the outside. So I'm going to have 2 on the outside, but I'm going to have another 2 on the outside, so I'm going to end up with a 4 on the outside. And then you can see left over, because I can't pair that 2 up with anything, I have a 2. So that means that this right here, 4 square root of 2, is the simplified version of the square root of 32. So I'm going to put this right here, 4 square root of 2. Plus or minus 4 square root of 2. So the square root of 32 simplifies the plus or minus 4 square root of 2. I'm going to subtract 6 from both sides of the equation. These 6's will cancel out, and I'm going to get x is equal to, now at this point, because this 6 does not have a square root of 2 with it, you cannot subtract 6 from the 4. So this is how you would write your answer, plus or minus 4 square root of 2 minus 6. So that would be an example of what I want you to do and how I want you to write the solution when you end up with a non-perfect square root. There we go.